This video is a review of the Edgenuity lesson, Solve Exponential Equations by Rewriting Bases. So when we have exponential equations, some people think, so I'm just going to do something totally separate from these examples. If I had like 4 to the power of 2x equals 16. A lot of times when you haven't solved these before, the impulse is, oh, well, to get to the 2x, I have to divide both sides by 4. That's not what's happening. Remember, division undoes multiplication. This isn't 4 times 2x. It's 4 to the power of 2x. So we've got to figure out, and what we do today, the method that we use, is to write them with the same base, because if the bases are the same, then the exponents have to be the same, and that's how we're going to set them equal to each other. So like on this first one, we already have both bases are 3. So if that's the case, for this to be a true equivalent equation, then these two exponents have to equal each other. So 2x plus 1 has to equal x plus 5. So if I subtract x and subtract 1, x is 4 there, and you can always plug it back in to make sure you get it right. So 2 times 4 is 8, plus 1 is 9, so 3 to the 9th. 4 plus 5 is 9, so again, 3 to the 9th power. Okay, so for example 2, we have an issue. Our bases don't match, so we can't just set the exponents equal to each other. And so what we have to do is we have to rewrite the base so that they do match. So I know that I can rewrite 16 and 32 with a base of 2. 16 is 2 to the 4th power, and then that whole thing is to the power of 2x. 32 is 2 to the 5th power, and then that whole thing is to the power of x plus 3. So we're still not at a point where we can just set them equal to each other yet. Remember, when you have an exponent on an exponent like this, you multiply them. So this is 2 to the power of 8x, and this one is 2. Now, don't forget, you're going to have to distribute. You're multiplying this whole x plus 3 by 5, so you have to distribute it to both parts. Now that our bases match, I can say, okay, now our exponents have to match. So 8x has to equal 5x plus 15 for that to be equivalent. So subtract off the 5x, divide by 3. X is 5 there. Okay, now on this last one, we have a fraction. So whenever you're dealing with fractions and then values that aren't fractions, you're going to need to use a negative exponent. So I know that 27 is 3 cubed, and that's still to the power of x plus 2. 1/3, in order to change that to a base 3, we need to use a reciprocal. So remember, when you have negative exponents, it flips it. So for example, like 1/4 to the power of -1 is 4, and like 6 to the power of -1 is 1/6. So they make reciprocals of each other. So I'm going to do 3 to the power of -1, and then multiply, because we have exponent on an exponent. So -1 times x is -x. Again, distribute here. 3 times the quantity x plus 2 is 3x plus 6. Now our bases match, so these have to match. Subtract 3x and divide by -4. And if I simplify this, it's going to be -3/2.